Okay, let's look at problem 667 in the ninth edition. This is it's a counters problem. So you have this truss, and it says the diagonal members in the center panels of the truss are very slender and can only act in tension. Such members are known as counters. Determine the forces in the counters that are acting. Sorry, the forces in the counters that are acting under the given loading. So what we're saying is it's either this one or this one is in tension. So the one that's in compression is as if it is not there. Okay, so what are we going to do? So I am a big fan of using the method of sections. I find that that's pretty much across the board the easier way to do things. So before we can do the method of sections, so I'm going to say do the method of sections through like here, cut through here, right? And then I'll say take this section right here. So before we can do that, we need to know what the force is here at H, and for the one I just did, we don't need it over here, but we can do it just for fun. So what are we going to do? Say take the sum of the moments at, say, H equals 0. Okay, so if we do that, you have 4.8 times the distance, so 1, 2, 3 times 3 11s plus 4.8 times 3 11s. Sorry, there's 2 11s on that one. And then plus 4.8 times 1 11. So you'll notice I'm leaving 11s because they end up canceling. So that's why. And then the 2.4 passes through H, so that goes away. So that's going to equal 2.4, this one right here, times 1, 11, and then plus that force at E, we'll call it EY times 2 11s. Okay, you'll notice 11s on all of them, so I'm going to get rid of all the 11s. That's just me being lazy. So it turns out that EY is equal to, oh, that's F, I'm sorry. I can't even read the only thing. So this is F. Here, we'll just fix that real quick. So Fy. So Fy is equal to 13.2. So then when I do my sum of the forces in y equals 0, tells me that H and the y is equal to 6. So I'm cheating and looking at the solutions while I'm doing this because this isn't the part that I care about. So I'm going to replace, I don't know what just happened. Okay, I'm going to replace this force right here. This has, come back please. Okay, that's 13.2, and this force right here is 6.0. Okay, so now let's look at our section that we cut off right here. So let's look at the free body diagram of that. So we have a simple triangle. Okay, so I have 2.4 coming in here, 2.4, oops, 2.4, there we go, coming in here. I have 6 coming up there. Now I have, so what did I cut through? This is the key. I cut through a force here. I cut through, this is CD. I cut through a force here, which is GH. Wow, sometimes the writing is not awesome on this thing. Cut through a force here of GH. Okay, and then I cut through these two things here and here. So the question is, I have to pick one of them, right? So I either have a force going off in this direction or a force going off in this direction, but not both. So how do I know which one I have? I don't, is a short answer, right? So I have to guess. But I am going to be smart, and I'm going to guess one that makes sense. And so how am I going to guess one that makes sense? Well, I'm going to come in here and say, hey, look, if I do my sum of my forces in y equals 0, I'm going to have 2.4, sorry, get rid of that, erase that, plus 2.4, right? So these two, and so those are my downs, my ups is going to be 6. So right off the bat, I have 4.8, between these two I have 4.8 going down, and this one I have 6 going up. So I know that my force has to also go down to get up to that 6. And so I'm going to know it's going to be this element right here, and that is dg. Okay, so therefore, let's come in and let's fix this. I'm going to say my downs equal my ups, and so this is going to be plus dg in the y is equal to 6. So dg in the y is equal to 6 minus 4.8, which is what, 1.2? Hopefully I'm doing my math right. Okay, and then I'm going to look at the actual triangle. So what's the triangle look like here? In this case, it's the triangle's here. So this is 9.6. This is 11. So therefore, sum of 9.6 squared plus 11 squared ends up being equal to, what is it equal to? 14.6? 14.6. So this is 14.6. So I'm going to replace dg with, so dg times the y portion of it is 9.6 over 11, sorry, 14.6 is equal to 1.2. So therefore dg is equal to 1.2 times 14.6 over 9.6, which is equal to 1.825 kips. So dg is the counter, so I'm going to erase this so we can see a little bit better, of this one right here. This is the one that is the counter, which means this one is in compression. So what would have happened? So right now, when I did this, I assumed that this variable, what if I had assumed this one right here? So then this one would not be there, get rid of that, and then I'd end up with a negative number, which is fine. Negative number just means that I drew it wrong. And I'm going to look at this and say, I drew this in tension, and so therefore if I drew it wrong, it means it's in compression. But I'm going to say, hey, wait, this member cannot be in compression. So think of these like ropes or cables, right? You can pull on them pretty hard, but as soon as you start to push on them, they're kind of worthless, right? And so this member is then in compression, so then you just throw it away and start over. Okay, so now let's do this section right here. So you could either do that section or this section, and it turns out either way is going to be fine. So the fact that I calculated both of these early on, I'm going to go ahead and just use this left side. So let's use the left side. So here we have a nice little triangle, which I just drew wrong. We have a triangle like this. We have a force here of 4.8, force here of 4.8, I have a force here of 13.2. I have an unknown in this direction, I have an unknown in this direction, which I don't have to find, right? It might be interesting, but it turns out I don't have to find them. And I either have a force off in this direction or off in this direction. So again, I'm going to do the same thing. I'm going to say, hey, I have 4.8 plus 4.8, so I have 9.6 going down. I have 13.2 going up. So right now there's clearly more going up than going down. So I'm going to add more going down. So I'm going to say this is the one right here. And this is BG. So I'm going to come in here and say sum of my forces in y equals 0. So my ups equals my downs. So 13.2 is equal to 4.8 plus 4.8 plus BG in the y. So therefore BG in the y is equal to, well, I don't have it right here. So is equal to, hold on, let me figure that out. So with my handy dandy math skills, I figured that that's equal to 3.6, but I don't want BG in the y, I want BG, but here again we have the same triangle as this one over here, so therefore BG, times 9.6 over 14.6 is equal to 3.6, so therefore BG is equal to 5.475. In tension, well, sometimes this just misses, doesn't it? Let's try that again. 475 in kips, and that's in tension by definition because it only makes sense if it's in tension. And there you go. Again, same deal. If I had done this one, so let's do this one just for giggles. Let's do this one real quick. Okay, so I'm going to say that this is the force here. This is element Z, E, or F. That is F, right? F, yeah, F, G, F, C. Okay. So this is the right answer. So now I'm going to do it wrong. Wrong way. Well, it's not the wrong way. It's just going to be wrong. Wrong answer. And I'll explain that. So I'm going to say sum my forces in y equals 0. So it's going to be 4.8 plus 4.8, my downs equals my 13.2 plus FC in the y, right? So therefore, FC in the y is equal to, in this case, is going to be minus 3.6, which the negative sign doesn't mean tension or compression. It simply means I drew it in the wrong way. So I can look at this, and if I drew it in this direction coming up here, that means I drew it in tension. So therefore, FC is in compression. But as we said, these are like ropes. So if you start pushing on them, what do? They just move. They don't take compression. And so all of a sudden, it's as if it's not there. So then I say, wrong answer, start over. And then I come over to here and do it this way. So you just guess. So you don't. Sometimes you can be smart, right? On these, you can see the numbers, the ups and the downs. You can see that clearly there's more up than down, so it has to go down. Over here, you can see there's also more up than down, so it has to go down. But sometimes it's not as obvious, and so you can just pick one. And if you get lucky, good. If you get unlucky, you're going to have to turn around and do it again. But then I'm going to pick this one, and I'm going to say, therefore, I got to get rid of this, and it is this force, my BG. And that's it. So I have the two members and the two counters, the BG and the DG. So those are the ones in action, if you will, the counters that have the forces. And the forces are at 1.825 and 5.475. There you go.